Hi everyone, there are some important questions for you. Okay, so let's start the lecture. Here is it possible to have 2d orbital? Also 1p orbital or 3f orbital. Okay, so let's start the lecture. First of all, you should know n. If we can understand n, then we can calculate value of L. Okay, what is n? N means principal quantum number, right? So principal quantum number means n is equal 1, 2, 3, 4. Okay, they are generally principal quantum numbers or main energy shell, right? So if this is nucleus, then this is n is equal 1, n equal 2, n is equal 3. Okay, for there are 4 quantum numbers. They are n, l, m, s. Okay, now we should know first n. What is n? N means principal quantum number. Principal quantum numbers means main energy shell. So n should be 1, 2, 3, 4 respectively. Similarly, it may be 1, 2, 3, 4, right? Okay, and then what is L? L is subshell. What is L? Is subshell. So L should be any value. L should have any value. It may be 0, 1, 2, 3. Okay, respectively. Then L, M. Right. Then M and then S. Okay. So for this purpose, we should generally know n and l. Okay, so this is not mandatory to know m and s. Okay, so here goes. Here for n. Okay, so for n and l, we should know value of l depends on n. N should be L should be 0 to n minus 1, 0 to n minus 1, 0 to n minus 1, 0 to n minus 1. For n is equal to, suppose for n is equal to, so also you should know SPDF. SPDF value of s is 0, this is 1, 0, 2 and this is 3, right? For n is equal 1, for n is equal 1, L should have, for n is equal 1, L is equal 0, right? 0 to n minus 1 or minus 1, 0, right? So this is 1s. So as for n is equal 1, L should have only one value, that is 0, and this is 1s. So 1p is not possible. So 1p is not possible, right? 1p is not possible. Okay, so this is the answer of second one. Okay, for n is equal 1, L should have 0, 1s. So 1p is not possible. Similarly, for n is equal to, for n is equal to, L is equal 0, 1, 0, 1. This is 2s and 2p. So 2d is not possible. Okay, and this is number 1 question, because if you put n is equal to, right, then there should be only 2 value of L, 0, 1. For subsidiary quantum number or azimuthal quantum number, L should have 2 value. For n is equal 3, n is equal 2, this is 0 and 1, 2s, 2p. So 2d is not possible. Similarly, for n is equal 3, for n is equal 3, L should be, L is equal 0, 1, 2. This is 3s, 3p, 3d. So 3f is not possible. So this is they are very important questions for both questions plus your basic knowledge. Okay, so 1p is not possible because for n is equal 1, L should have only one value, that is 0. So there is no value for having a value p, we should have 1, but L is always less than 1, that is why 1p is not possible. Similarly, for 2d, L should have 2, but for n is equal to, L should have 2 value here, 0, 1. So 2d is not possible, right? Is it possible to have 3f? Also not possible, because for n is equal 3, n should have 3 value, 0, 1, 2. So 3s, 3p, 3d. So 3f is not possible. I think you got the point, and this lecture is very much easy, I think. Okay, thank you.